Hello chemists, this is Ms. Placino and you're watching lesson 5.2 on naming covalent compounds. In today's lesson we're going to discuss how the formula and the name of covalent compounds is determined. A couple quick goals for today's lesson. First, we need to recall what covalent bonds are and what sorts of elements will bond covalently. Second one is the big one for today's lesson. We're going to name binary covalent compounds and be able to provide the formula when given the name. And finally, we'll talk about 3 exceptions to the nomenclature system that we're going to be using that you need to be aware of. All right, let's get started. So we're going to be looking at binary covalent compounds. Binary meaning consisting of 2 different elements. Covalent, hopefully remember that means that electrons are being shared between bonding atoms. And you might remember that covalent compounds tend to form between 2 covalent bonds, and ultimately covalent compounds form when at least 2 different non-metallic elements bond together. They have similar electronegativities, so we see sharing instead of a transfer of electrons. If you did the reading, you probably noticed that prefixes are used. Like di, tri, tetra, so on and so forth, when we name our covalently bonded molecules. We didn't need them in ions, but we definitely have to have them in covalently bonded molecules. Here are 7 different examples of how nitrogen and oxygen can bond together. The blue atom is nitrogen, the red atom is oxygen, and they don't always combine in the same ratio. Unlike ionic compounds, where the charge of the ions dictate how many of each have to be there, with covalently bonded molecules, a whole bunch of different possibilities are perfectly valid. So I can't just call these nitrogen oxides. Technically, they all are nitrogen oxides, and that does not provide me with any information. Once I put prefixes, I might call this nitrogen monoxide, nitrogen dioxide, dinitrogen monoxide, and those prefixes can start to denote how many atoms of each element are present in the compound. So we never see them in ionics. They are extremely important in covalently bonded molecules. Let's quickly review the prefixes. All right, we won't give you anything over 10 of the same atom bonded, so we don't need any prefixes above 10. 1, mono, 2, di, 3 is tri, 4, tetra, 5, penta, 6, hexa, 7 is hepta, 8, octa, 9, nona, and 10 is deca. You probably noticed, with the exception of di and tri, all of the other prefixes have their last vowel in parentheses. This vowel can be dropped if you name something and you end up with 2 vowels next to each other. Like tetraoxide, for example, would sound kind of strange. So we would drop the A from tetra and we'd call it tetroxide. At this point in the game, since we're just learning, I will definitely let that mistake slide, but be aware that you shouldn't end up with A and O or 2 O's next to each other. Other rule you should be aware of, do not use mono for the first element. Mono is the only prefix that is only applied to the second element, and hopefully we'll see that as we start doing some examples. Let's look at one. My guess is you knew how to name this compound well before you got to my class, CO2. That is, of course, carbon dioxide. If we think about what's happening to the names of the elements, well, carbon just stays carbon. So the first nonmetal is going to keep its name. Don't make any changes to it unless you need prefixes. The second nonmetal, oxygen, became oxide. Just like with ionics, we're going to drop the ending and add the suffix "ide." Where did that di come from? Oh, right there. There are 2 oxygen atoms present, so we use the prefix di. Prefixes denote subscripts. Note that it's not called monocarbon dioxide, just carbon dioxide. Again, do not use the prefix mono for the first element. Let's go in the opposite direction. Dinitrogen trioxide. All right, let's see. So I've got di, that means 2, nitrogen. Okay, so I need 2 nitrogen. Do that with subscripts. Tri is 3, oxide. Oh, that's oxygen. And 2O3. Yeah, that's it. That's all there is to it. It basically tells you exactly what you need to write. So the prefix, again, just Matches the subscript. I need 2 nitrogens in this case. I need 3 oxygens. One really important point. Do not reduce the subscripts or the formula to the simplest terms. That's got to be the most common mistake I see with taking covalent compound names and turning them into formulas, is students go through and reduce the subscripts. Your prefixes and subscripts have to match. Do not cancel out or simplify. That is only for ionic compounds. Just a little bit more before we get into some practice problems. Please keep in mind that these naming rules apply only to binary molecular compounds. And again, just compounds consisting of 2 different elements bonded together. From like bio class, you might remember C6H12O6. We can't name that using our covalent binary naming rules. It's got more than 2 elements bonded together covalently. It gets named according to a different set of rules. That's of course glucose. And that's literally what I just said. Multiple elements, more than 2, more specifically, present in a covalent compound, we use a different naming system. So we cannot name those types of covalent compounds at this point in time. We're going to treat the metalloids as though they are nonmetals. So elements like silicon, germanium, arsenic, etc., they tend to have high enough electronegativities where they're going to bond covalently with other nonmetals and bond more ionically with metals. So we're going to treat all metalloids as though they are nonmetals. All right, let's try out some practice problems. My suggestion, pause the video, give these a shot, and then start it back up when you're ready to check your work. Let's see how you did. SiO2. And there's an example of silicon, a metalloid. We're going to name this covalently. SiO2 is silicon dioxide. Silicon di tells us 2 oxygens. That's it. SeF6, selenium hexafluoride. CO, carbon monoxide. CCl4, carbon tetrachloride. Let's go in the opposite direction. We'll take the name and turn it into a formula. Diarsenic, so I need 2 arsenics. Pentoxide, there's an example. Instead of pentaoxide, it's pentoxide. 2 arsenics and 5 oxygens. As2O5, phosphorus triiodide, Pi3, sulfur dioxide, SO2, dinitrogen tetroxide, N2O4. It has to be N2O4. It is incorrect if you've reduced it down to NO2. Isn't that the same? No, those are 2 different things. That's dinitrogen tetroxide. This is nitrogen dioxide. Those are not the same molecule. Do not reduce your subscripts when naming covalently bonded molecules. All right. Most students find naming covalents to be easier than naming ionics. There's just less work to do, really, but you should still get in a lot of repetition, get comfortable with these, and make sure you're not making careless mistakes like reducing subscripts down, or kind of like flip-flopping between like hexa and hepta. It's another really common mistake. All right, to wrap up, I want to talk about 3 exceptions to these naming rules that we've been applying. So certain substances have what we call a common name, where we're not going to use the same set of rules that we just have been applying to all the other covalents. The first molecule I know you are familiar with. It's not dihydrogen monoxide. You don't sound super sciencey when you ask for that instead of water. This is not the correct name. H2O is water. It is incorrect to call it dihydrogen monoxide. Same deal with NH3. You probably have this at home, like maybe under your sink with all the other cleaning supplies. Not bleach, it's the other one. Yeah, like Windex, the active ingredient, we don't call it nitrogen trihydride, we call it ammonia. So again, do not name it nitrogen trihydride. That is not right. It has to be called ammonia. And last but not least, CH4. We don't call that carbon tetrahydride. It also has a common name, and that name is methane. Fair warning, I am going to try to trick you on quizzes and tests. I usually get like no one with H2O, like that's been ingrained since elementary school, you know that's water. But after I have you name a couple applying the rules, and then I throw a curveball at you like NH3 or CH4, I will trip people up. So telling you now, don't fall into that trap. Commit those two to memory: NH3, ammonia, CH4, methane. All right, I think that wraps it up for today. Thank you for tuning in, and I hope you found this video helpful.